Welcome to Lesson 6, where we investigate the distance between two rational numbers. And I am really hoping that this idea of distance, this word distance, is going to key you into the concept that we are going to be discussing. Some of you may have that in your mind already. I sure do hope so. Okay, but we'll get to that later. I won't give it away right now. Just wondering what you're thinking. Actually, if you have an idea, just for shakes, why don't you go ahead and write it over here somewhere. Write it over here. What do you think? What do you write about in this area here? What do you think? What concept are we going to be talking about? What does this term distance kind of tip you off to? What concept? Okay. All right. So here is this. Now this is a little bit of a sort of a game, and in class you would have played with another person, okay, another student, where you would have had person A and person B, okay. But here we're just going to go ahead and do it together, and the idea is using these number lines, or using the number line, both persons A and B would go ahead and determine the distance between the integers given, okay. So a good way to do that, actually, for some of you, maybe you might like to do this. I think the highlighter idea is a good one. Okay, so if you take a highlighter, so in this first one, we're trying to find out what the distance between -4 and 5 is. Now these are kind of small, these numbers, but I'm going to go ahead and there. So I start at -4 and I go to 5. Okay, so I highlighted that area. This is the area here that I am concerned with. Okay. All right, that's what I want to know. I want to know what that distance is. If I had a little ant moved from -4 up to 5, okay? So if we counted that, we know we go 4. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. That's 9. So this is 9 units long. This distance here. This distance is 9 units, okay? This is 9 units. All right, so if we go down to what is the distance between, we're going to continue with person A, pretend person A is doing this on their own first. What is the distance between -5 and -3? Then we find -5, and we go to -3. Okay, actually I went a little bit farther, but that's fine. You kind of get the idea, okay? So right there from -5 to -3, and we can count 1, 2, 2 units between those two, okay? Alrighty, and then the last one here, what is the distance between 7 and -1? Start at 7, go down to -1, right there, okay? And again, this is the distance here between 7 and -1. And if we count those units, we start from 7 and work down, so 7 to 6, that's 1, 2, 3, 4, 5, 6, 7, and 8, okay, so that's 8 units. So in this case we have 9 units here, 2 units there, 8 units there, and these are all distances, okay, the distance between those two points, okay, or two integers. Now person B would have been doing this on their own, and would have let's see what they would have gotten. We can just take a look and go ahead and see. So now what would person B, and again, if you're doing this together, you're not really quite, you might not be aware of what each other has, but I guess you would be if you're looking at these sheets. But anyway, you can notice what happened here. What they've done is they've just taken these integers and they kind of swapped them here, okay? From here it was from between -4 and 5, and in this case over here it's between 5 and then -4. Now let's see if that is different. Let's see. So we go start from 5, go down to -4, and then we count in between, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so again, another 9 units in between, and now you could probably just make a pretty good guess that swapping these or flipping these two numbers, -3 and -5, isn't going to do much different than we saw up above. And you would be right. Right there we have another 2 units, just like this. So this was the same as this was the same as this, And then finally, between -1 and 7. So we just start and we go. We're moving in a different direction in terms of where we start and where we end. But once again, we've moved 8 units here. So these are the same as well. Okay, the same as well. So let's just talk about this for a little bit. Maybe we can get to that concept then. Okay. You can see, and one of the questions I would have asked you in class would have been, are you and your partner's distances, do they end up to be the same? And yes, in all 3 cases, they are indeed the same. So another question would have been, why? Why is this? Why did you both get the same answers for these problems? Well, very simply, the endpoints, okay, were always the same. All right, so they were always the same. In this case, you're always going to go between -4 and 5. It's just that in the first case, person A moved up while person A moved down. Okay, but again, they've gone the same distance. And the same case with the other 2 problems as well. Okay, the distance is going to be the same between person A and person B. Okay, so this idea of using a number line to find the distance between 2 rational numbers. Okay, now these are integers we're talking about right here, whole numbers. Okay, whole numbers. Now, to use a number line to find the distance between 2 rational numbers, would you consider that very efficient? Okay, so we're talking rational numbers. We're talking about maybe we have 1.5, 0.83. Okay, we have all of these numbers. Not as easy to locate on a number line. And again, we can customize our number line to look differently. Okay, to include fractions and decimals in it. But no, I'll just cut to the chase here and tell you no, it's not a very good way to do it. Okay, to count on. We don't want to count on this for rational numbers, but here's the big question. Okay, what concept are we talking about here? What concept represents the distance between a number and 0 on a number line? What is that? We've talked about that before. And that's right. I think many of you will recognize what we're doing here as absolute. Okay, I gotta spell it right. Absolute value. Okay, if you remember that absolute value, I'll just put the little symbol for absolute value around there. Okay, so if we're looking at if we look at the top one, for example, here, and I'll look on person A's problem here. If we're looking at the distance between 0 or 5 and 0, okay, 5 and 0, we get 5, right? And that's right. That's right. This portion right here. Okay. So this is going to be the same because this is from 0 to 5. That's going to be 5. And now we can look at, remember, we could have got -4 to 0, and that's going to be 4 units. Okay. Because again, it doesn't matter. Even though that is a -4, we're on the negative side. We're finding absolute value. We are finding a whole number. Okay. So these are going to be 9. That's going to be 9. It's going to be the same over here because we're doing the exact same thing. So if we're looking at each one of these as their separate own absolute value, okay, this one 4, this one 5, they're going to be the same, okay, because they're the same 2 endpoints. All right. This, of course, will work with the other ones as well. For this one, okay, they will work exactly the same. So what we are actually looking at here is we are looking at the absolute value of the distance between these pairs of numbers. Okay. All right. Okie doke. So exercise 2. What I'd like you to do now is I'd like you to work. Go ahead and pause for a bit and a few minutes and go ahead and work on your own. And I want you to use a formula to find the distance between each of the 2 given endpoints. Okay? All right? So, what I mean by that, all right, well, in terms of formula, okay, so if I looked at, if we had, I'm going to go ahead and just erase this one. So if we look at this one, for example, this first one here. So look at this one, the 5 and the -4. So what I'm doing is, again, of course, I'm summing because I'm combining these, okay? So if I said, I would say this, I would say to find the distance against absolute value, we would say the absolute value of 5 plus -4, okay? 5 plus -4. Now a 5 plus a -4, okay? Actually, I'm sorry. That is incorrect. I'm sorry, because we're looking at distance. We're subtracting. That's right. We're trying to find the distance between. So we're going to go 5 minus a -4. Okay, 5 minus a -4. That would be the same as adding a -4. So of course this is going to be 9. So that equals the absolute value of of 9, which is the same as 9, of course. Okay, but now if we look at it the other way over here, when we looked at it a little bit differently, okay, we had the absolute value of -4 minus 5. Okay, so -4 minus 5, that actually equals the absolute value of -9. Okay, so the way these combine and these combine is different in the sense that here is going to yield you a negative number here. We're finding this distance, and here a positive number, but the fact that they are both absolute value makes them exactly the same. Okay, so we are finding the absolute value of these distances. Okay, so go ahead. Let's do number 2. Let's do A together. Okay, so A says use the number line to answer each of the following questions. That's exercise 2. Okay, so what is the distance between 0 and -8? Okay, 0 and -8. Now 0 and -8, of course, we can just look at it this way. We can hop on over, go all the way down. Okay, oops, sorry, negative to -8. That is right there. Okay, 0, -8. We can hop on over. Boom, 2, 3, 4, 5, 6, 7, 8. Okay, probably the easier one here. But if we went ahead and just created an equation, but we created we used our formula. We would say the absolute value of 0, absolute value, minus 8. Okay, 0 minus -8. All right, so 0 minus -8. Okay, absolute value of 0 minus -8, which is going to be 0, absolute value of 0 plus 8, which equals, of course, is going to be absolute value of 8, which equals 8. Okay, so again, pretty simple to see. Okay, the distance between 0 and -8 we know is 8 units. Okay, that's something we all could have seen really quickly. Okay, but what I want you to do when you do these is don't forget to write it out formulaically. Okay, so in a formula style. Okay, using some of the rules that we've already learned in prior units. Okay, and again employing the absolute value symbols. All right, so go ahead and do B and C, and then come back. Okay, I'm back, and here we go. Let's look at B. What is the distance between -2 and -1.5? Wow, this is quite a short little jump, huh? Truth is, we're starting from -2 and just going. There is -1.5 is right there between -2 and -1. Okay. Now you can see that's maybe it's easy enough. Okay, we can see how big of a jump it is. But then if we apply our formula, again we have the absolute value of -2 minus -1.5. Okay, that's absolute value of all of that inside of there. Okay, and again, remember that where this minus number comes from is we're looking at distance. We're trying to find out the distance between these two rational numbers now. Okay, now we're in the zone of rational numbers, not integers. So we have -2, and what that is actually that equals the absolute value of -2 plus 1 1/2. And again, if we add that -2 plus a positive 1.5, we're going to get -1/2, and that of course equals 1/2. All right. So that distance between those two rational numbers, -2 and -1.5, is 1/2. Again, easy enough, but if you would please just not just withstand the temptation of just writing this answer, and please go ahead and include all of this in your answer. Okay, so I will actually I'll be posting an assignment to have you guys and girls but take a snapshot of some of your problem set so I can see that you are indeed doing that. Okay, I want you to be thorough. That's one thing about algebra that can be frustrating for kids, is that you need to write things out. You need to write your answers out. That's a huge portion of how you are graded on algebra. Okay. All right. So C here. Okay, we have what is the distance between -6 and -10? Again, this is something that I'm sure many of you know already. Just by looking at it, you know it. But let's go ahead and do it. And here we go. We have -6, -10. Okay, we have that distance right there. But let's go ahead and create our our formula. So that is the absolute value of -6 minus a -10, which equals absolute value of -6 plus 10. Okay, which equals the absolute value of a positive 4, which of course is 4. All right. Alrighty, did we? Yes, indeed, we did that. Yep. Okay. All right. So yeah, you can see that it is 4. Again, very easy enough. Just go 1, 2, 3, 4. We can see there's a distance of 4 units between those. But if we just if we apply that, apply the formula, just so we can see what is actually going on there. Okay. Alrighty. So let's move on here. We have example 1. So what I'd like you to do is just to go ahead and do that example 1. And then come on back and take a look, and we could do it together. Okay, so if we follow these steps here, example 1, formula for the distance between two rational numbers, looking at finding the distance between -3 and 2, and let me reiterate, I know how easy this is to do, but let's go ahead and just apply the formula. Okay, so it says start at an endpoint. And what's interesting here is that it can be either endpoint. All right, so we have -3. Let's start at -3. We go -3. We can go ahead and we go 1, 2, 3, 4, 5. Okay, if we're moving that way, we move 5. If we move from 2, 1, 2, 3, 4, 5. That's also 5 units. Okay, it's the same distance between the two. Okay, so same distance. Now, in the same vein, if we do it by a formula, so using a formula, what we would have had for my first, actually, why don't I just do that one in different color? So do my first one in red this way. Okay, so the way this one looks would be the absolute value of -3 minus 2, which equals absolute equals absolute value of -5, which equals 5. Okay? All right, and now for the other one, if we just started from the 2, we could say the absolute value, that one was the absolute value of 2 minus -3, okay, which of course we know equals the absolute value of 2 plus 3, okay, which again equals the absolute value of 5, which equals 5, okay? All right, and this one over here, of course, equaled 5. All right, so these are the same, okay? Now, if you want to, but when we create a formula, we create it one way. So, so for two rational numbers here, and you can see here's a definition down here, for two rational numbers, P and Q, the distance between P and Q is the absolute value of P minus Q, okay? So this P minus Q, again, you know, P is our, is that first addend, okay? And then, the first addend, and then the Q is the second addend, all right? Now, what we come to learn, okay, is that if we change it around, if we started with 2, as we did here, then that becomes the P, and the -3 becomes the Q. Okay, over here we had the 3 as the P, and the +2 as the Q. Okay, so for whichever way you do it, doesn't really matter. So just as long as you know this formula, for two rational numbers P and Q, the distance, and again we know what that distance is all about, between P and Q is the absolute value of P take away Q. Okay, so example 2 is change in elevation versus distance. Okay, so we're going to look at this idea of change in elevation, and we're going to compare it to this idea of distance. And this first statement here is pretty much where this difference comes into effect. Distance, we always consider distance as being positive. Okay, distance is positive. It's always stated in positive terms, okay? If I walk down the street, I walk to Orchard Supply Hardware, okay, half a mile away, all right? When I walk there, it's a half a mile. When I walk from there back to home, it's also a half a mile. I don't say it's a negative half mile, okay? There's no such thing as moving, even though if I climb up a ladder, I may climb up a ladder 10 feet. When I climb down the ladder, I climb that same 10 feet. I don't climb a negative 10 feet. Now, again, we'll talk more about this. I think you understand it intuitively, but sometimes when you're applying that to mathematically, there can be a little bit of confusion, and we'll talk about that here. But this whole idea of distance as being positive is very, very important. Now, change in elevation, change in elevation or temperature, okay, those two may be positive or negative, okay, depending on whether it is increasing or decreasing, so going up or going down, all right? So here's an example. A hiker starts hiking at the beginning of a trail at a point which is 200 feet below sea level. Okay, so that below should key us into something. He hikes to a location on the trail that is 580 feet above sea level. Okay, and here's that above. Very important. And stops for lunch. So, first question here asks, what is the vertical distance between 200 feet below sea level and 580 feet above sea level? So, how far, okay, not how far along the trail he's gone, because that could be very, very different. But what we're talking about right here is how much vertical distance did he actually gain. Okay, so he could have been, the trail. I'm just going to draw a little picture of them and erase it after this, though. So he's walking along. He's at below sea level. He's going up, and then he ends up here somewhere. Okay, so he started out as negative 200. Okay, then he ended up at 580 feet above sea level. Okay, all right. So we're answering this question here: how far or how much elevation did he gain? Okay, you can, I hiked Mount Whitney this past summer, and truth is, you can go miles and miles and miles, and gain just several hundred feet in altitude or in elevation. Okay, so that's not the case of how long he went how far he hiked, but how much vertical distance did he gain. Okay, real easy way to do this is just to apply what we know and apply our formula. Let's go ahead and do it. So we're trying to find distance. So let's use our little distance thing. So it's the absolute value where he started, which was negative 200. Again, we're subtracting because we're finding distance, okay? Trying to find that space in between, okay? So minus a positive 580, so it just looks like that, okay? Because that's where we ended up right here, positive 580. So that's going to go ahead, that's going to equal which actually equals a 2, I don't know why they're changing this here, okay? But yeah, so this is going to be, okay, you can see this right here. It's a negative 780. I don't know, I was looking at my notes here, and it was kind of weird the next step they put. So we're just going to go ahead and leave it like that. Oh, I see what they did. Okay, I will do that just so you can see the similarities here. Okay, so what they're doing is they said negative 200, and again, plus a negative 580, which is the same. It's the same thing, but just showing you that we are. Remember, we have this idea of adding or this summing, okay? But it's going to equal the same thing, which is going to be the absolute value of negative 780, okay? Which of course equals 780. So what we learn from this is that his vertical distance that he gained was 780 feet. Okay? Now, interesting because, again, he ended up at just 580 feet above sea level, but he still gained 780 feet in elevation because he started, of course, below sea level. Okay? Again, not so complicated when you just apply the formula. Okay? Apply the formula. All right? So, this part 2 here asks you then, how should we interpret, you're going to see this word, get used to this word, interpret 780 feet in the context of this problem. I guess I just said it. Just said it before that. When we interpret, it means how do we explain, how does it fit into this problem, this idea of being in this context? Well, very, 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 very to the point. I mean, the hiker gained 780 feet in elevation between where he started and where he ended. Okay, and ended. All right, and again, it looks hard to believe that he could have gained, more elevation than higher elevation than where he ended. But the truth is, this 780, this is the elevation he gained. This 580 here, this is where he ended up. Okay, and if you start in the negative territory, which he did, all right, it's not impossible to see. But again, by applying this formula, Doesn't need to be that complicated. Okay, so the next part of this problem here says B is after lunch, the hiker hiked back down the trail from the point of elevation, which is 580 feet above sea level, to the beginning of the trail, which is 200 feet below sea level. Okay, so we're going back, we're going the other way, and the thing is we know, because we've done these problems before, earlier in this lesson, and here's a problem that actually uses a vertical number line. Again, we don't see this very often. Like I told you, temperature is usually what we see a vertical kind of vertical number line use. Okay, but if we just did this, we can just say that here we go. He is at 580. Okay, this is our positive 580. So then after lunch, he is going to go ahead and move down to negative 200 where he started. Okay, so true, before lunch he went this way. After lunch he went that way. So here's before, here's after. Okay, and pretty obvious, you can see that they're exactly the same. Okay, by looking at it in this term, they look exactly the same. All right, so what are we saying? We're saying that now if we were going to go ahead and plug it into the formula, and this is what this part here is asking us to do, what is the vertical distance between 580 feet above sea level and 200 feet below sea level? I think you know where this is going. Again, absolute value of 580 minus a negative 200. Okay, all right, we know what that is. Absolute value of that equals, of course, 580 plus 200. Okay, and that, of course, equals the absolute value of 780, which equals 780. Okay, so we have our distance again, 780 feet, and of course that is exactly the same as we had beforehand, because just turning this around does not affect the distance. Okay, it does not affect the distance. It does not matter that we went from the low point to the high point, or the high point down to the low point. These were both going to be the same, give you the same exact answer. So therefore, to finish up this problem, what is the change in elevation? And of course, the change in elevation is 780 feet. Okay, just like the other one was. Okay, this next exercise 3 is a bit of a, not going to say a puzzler, but it's one that I want you to puzzle on. And please, I'd love for you to work this out with your parent teacher or somebody else in the room, maybe a peer. Okay, so here we go. What you're going to do is you're going to find, here's the scenario. The distance between a negative number and a positive number is 12.5. Okay, that's what you were given. Distance, 12.5. What are the numbers? Okay, and I will tell you right now that there are multiple answers, just so you do not have to deal with that hair pulling scenario. Okay, yes, there are multiple answers, but just this right here, the distance between these two numbers, and again, got to make this very, very important here. Very important, between a negative number and a positive number. Okay, so when we're looking at the number line, we are moving either from this side of 0 to this side, or from this side of 0 to this side. Okay, so got to, if you're tempted to start from 0 and just go to 12.5, that'd be easy enough. Okay, but that wouldn't be correct. Simply because if we think about it, 0 is neither negative nor positive. Okay, 0 is 0. Okay, it doesn't have a negative connotation. There's no positive connotation to it. Okay, or it's not denoted as either. So you need to move from either from the right side to the left or the left side to the right. Okay, so go ahead and puzzle on that. Please use a number line to help you out if you need, and come on back and let's look at some possible solutions. Okay, we're back to look at this exercise 3, which I hope you had some fun with and saw that there were indeed several variations of answers. Okay, so anyway, I made a number line, and you can see black on the right side of the 0, which indicates positive numbers. Red on the left side of the 0, which indicate negative numbers. Just something that, I don't know, maybe you've heard before, but when someone says you are in the red, that means you owe money, negative money. And when you're in the black, you positive money, okay, or you have extra money. All right, so that's why I use the black and the red, and I can't fit those minus signs on the left there. It looks so sloppy. So anyway, let's go ahead. Hopefully you all had a good time with this, or a fun time with this. I just thought, hey, if I can't start from 0 and move that way, then I'm going to just go ahead and start from 1. So if I'm starting from 1, or negative 1, I'm sorry, and I'm going to go to positive 11, I know that that is going to be correct, okay? And if I just look at that in terms of formula, what I'll say is I went from negative 1, again I'm going to find my absolute value, negative 1, and then I'm going to the right, so actually I'm finding distance, so I'm not saying that, I'm finding distance, so then I go minus a minus 11, okay, and that's going to equal the absolute value of negative 12, which of course is 12, and I can see that I have gone 12 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, and I know if that's one solution, I can just keep moving in this case to the left, start at negative 2 and go up to negative 10. To positive 10. Okay, so I am creating lengths of 12 units, but just moving 1 to the left in each way. So if I moved 1 to the left and went to actually negative 2, I would need to move 1 to the left of the 11, which I would go to 10. Okay, and hopefully you guys thought the same way. And also, I could have done my formula that way, or I could have, for my first example, I could have also went to the absolute value of 11 minus a negative 1, okay, which was those the two starting points of my first one. Let me just have a different color just to talk about those. But remember, I started at 11, then I ended at excuse me, the negative 1. Okay, so therefore absolute value of 11 minus negative 1 equals absolute value of 11 plus 1, which equals absolute value of 12, which of course equals 12. Okay, and again that's the same thing. So hopefully you had some very similar answers, or and thought it was a lot of fun. One thing I would like to just alert you to, not as simple as just looking at the different integers here. So you have 11, and then I have 1 here, and I know that I add those two together, and it's 12. Okay, and 10 and 2 work the same. Okay, just really difficult to work that, because you can end up in a place where you are looking at negative numbers. Okay, so and when you're on a totally negative side, from a negative value to another negative value, that's going to throw you off a little bit. So let me just say again, hopefully I'm making sense. I might not have made sense. So with this problem, we asked for the distance between a negative number and a positive number for a very good reason. Okay, for a very good reason, because what can happen on the other side is not going to look very similar. So if you go from if we changed this, and it could have been anything from a negative number to a negative number, or a positive number to a positive number, you're going to see. Let me just see if you can see the difference here. Now, when we had that negative number to a positive number, or positive number to a negative number, that did work out. It seems like you could have actually just added the integers, no matter what they were, negative or positive, and gotten 12, and you would have been right, okay? But what works out later on, though, if you're going to, okay, so if we're going to, I have to add a little bit here. Add right here, so 13. Okay, so with 13, I mean, if I was going to do on the positive side, I could go from 1 to 13, okay? 1 to 13. Now that is indeed 12 units. Okay, it is 12. Okay. Oh shoot, I was doing 12 and it was 12 and a half. I just realized that. You guys think I'm crazy by now? How many minutes have I been talking about this and it's been wrong? Well, I mean, you can get the idea. I mean, if I were just to do this all over again, it would have been just moving over another half a unit. Okay. I will be doing this again, so hopefully you'll see it, and I'm sure you'll understand it. Okay, it just needed to be 12 and a half in between. So sorry about that. Anyway, I was back on this whole idea of being exclusively on the positive side here. Okay, exclusively on the positive side. What would happen here if you went ahead and said, "Oh, that's a really good strategy. How about 1 plus 13? Ooh, that's going to be 14." And you're going to say, "Oh, that can't be right," but it is right. That's why you can't rely, if you did see that, don't rely on just finding integers that equal 12, okay, and that's going to be the correct distance, because it wouldn't quite work out that way, okay? All right. Well, I hope I haven't confused anybody here. You know, I'm going to take just a few more minutes. Let's go ahead and do this using the right number, 12 and a half. Okay, I'll just do it again, just for the sake of the cause here. Okay, well, here I am back. Maybe I'll do it correctly now. Okay, so in this case, where did I start? I started right here from negative 1/2. Okay, negative 1/2. So 1/2 on the left side of the 0, and then I go to a positive 12 over here. Okay, and again, if I apply my formula, negative 1/2 minus a positive 12, okay, absolute value of all that equals absolute value of negative 12 and a half, which of course equals 12 and a half, because absolute value, or distance, is always positive, okay? All right, and again, several examples. Just keep shifting 1/2 to the left on both sides, and you'll have several answers. Okay, so exercise 4, I'd like you to go ahead and try these on your own, and then come on back, and we will go over those. So that's actually A, B, C, D, and E. So if you would go ahead and work those out as best you can, take a few minutes, maybe, I don't know, 10 minutes, and come back, and I will go over those with you. Okay, so the first one asks you to use the distance formula to find each answer. Support your answer using a number line diagram. Okay, you know, if you're asked to do something like this on any kind of assessment, you need to do it. Okay, it's not there just for you to look at and ignore. Okay, you need to do it. So I'm going to apply my formula first. So I'm going to go ahead and find the negative 7, absolute value of negative 7. Minus 4, okay, or that also equals, just to keep reiterating here, a negative 7 plus a negative 4, which equals, of course, absolute value of negative 11, which is going to equal, hold on a second, what am I doing here? No, minus, I'm sorry. Could I begin again? Okay, moving too quickly there. I just threw myself off. Okay, so anyway, here we go. I should have done it with a number line first. What do we do with a number line? I'm going to do a number line first. Dang it. Okay, Here we go, I've got my 0. Negative 1, 2, 3, 4, 5, 6, 7, negative 7. And then 1, 2, 3, 4, here's my negative 4. So if I check it first, ta-da, I know I need to get 3 as my answer. Okay? So sorry for that first little blunder. All right? Anyway, there we go. 3 is my answer. Now, let me go ahead and apply my formula. And that's always a good thing to do, is to support it with that number line, because I knew I was wrong right away. But so here we go. Absolute value of negative 7 minus a negative 4. I'm not sure what I did before. Okay. And that equals, of course, negative 7 plus 4, which equals the absolute value of negative 3, which equals 3, as we found out. Okay? So sorry. So here we go. B asks us to find the change in temperature. Change in temperature. If the temperature rises from negative 18 degrees Fahrenheit to 15 degrees Fahrenheit, we will go ahead and support that with a vertical number line. So let me make that vertical number line here. Place 0 in the middle here. Okay, so we have, let's do it in 5. So here's 5, 10, 15. That's all we're going to need. Then we got 5, 10, 15, 20. So our negative 18 is about, excuse me, about right here. That's negative 18. And then we have 5 to 15, and our 15 degrees Fahrenheit positive is right there. So between these two, so if I go from negative 18 to 0, I know that's 18 in distance, 18 units or 18 degrees, and then from here to here is another 15. So my answer is going to equal 33, because what I've done is I've just added 18 plus 15, because I'm working my distance on either side of the 0, okay, the downside and the upside, negative side and positive side, okay. So if I was going to go ahead and then just apply my formula, I would do absolute value of negative 18 minus 15, okay, which equals, yeah, you could also say, this is where I messed up the other time, negative 18 plus a negative 15. That's what I was trying to do up there, but I was wrong. And then that equals, of course, absolute value of negative 33, which equals 33. Okay, and you can see we have matched right there. Okay. Alrighty, so C, it says, would your answer for part B be different if the temperature dropped from 15 degrees Fahrenheit to negative 15 degrees Fahrenheit? So would your answer be different, okay, if it dropped, all right? And then you need to explain that. Oh, I guess you've done that already. I'm sorry. I'm not going to stop here. So, yeah, and the question is, would your answer for part B be different if the temperature dropped from 15 degrees Fahrenheit to negative 18 degrees Fahrenheit? Now, again, we're looking at a, and again, we should probably go look back at B, because there's one thing in B that we didn't quite take a look at. Here's change in temperature, okay? This is really important because we're not saying distance. Now, over here, we had, we're talking about distance. We're finding the distance between those two numbers because they're just arbitrary numbers. We don't know what they actually are, you know, what they apply to, what their context is, okay? So therefore, we're going to have a one basic absolute value answer, okay? Now, in this next one, though, we're finding the change in temperature, which is really important, and the reason is there is, we talked about this earlier in the lesson, is that temperature and elevation, the change in those is not always positive, as is distance, but it can be. So in this case, when we went from negative 18 Fahrenheit to actually 15 degrees Fahrenheit, we, our temperature actually increased increased 33 degrees. Okay, so this is really important. I didn't emphasize this. I should have, and hopefully this makes sense to you. But it increased 33 degrees. Okay. Okay, so now we're back to this question here then again, this C question. So would your answer for part B be different if the temperature dropped from, now we're talking about temperature dropping from 15 degrees Fahrenheit down to negative 18. In terms of distance, didn't ask that. Distance would have been the same. We're talking about 33 units, but now if we look at if we look at that, I guess we could use this one here. So now let's say if we're going to go from, we'll use a different color here. We're going to go from 15 to 18 this way. Okay, you can see that 33 is still 33 units, but what's happened here is that we have lost 33 degrees. Okay, or the temperature has decreased. So the answer to this would actually be yes. It would be different because the temperature would have decreased. Would have decreased 33 degrees. Very, very important to make that distinction. Okay. Okay, this next problem, D, it says Beryl is the first person to finish a 5K race and is standing 15 feet beyond the finish line. And I just went ahead and put Beryl right over there, as you can see right there. It's about 15 feet beyond the finish line. Finish line right here is 0. Another runner, Jeremy, is currently trying to finish the race, and it's approximately 14 feet before he reaches the finish line. So there's Jeremy right there at about negative 14. Okay. So what is the minimum possible distance between Beryl and Jeremy? Now we have right here from Jeremy. It still has 14 feet to go. So that's it's a negative 14 on that side. So he's 14 feet away from the finish line. And then Beryl is 15 feet beyond the finish line, just standing around waiting. And if we go ahead and we look at that, we can see that it actually is 29 feet, that distance. Okay, but then if we go ahead and of course apply our formula, we could put in negative absolute value of negative 14 minus 15 equals absolute value of negative 14 plus the negative 15, which equals negative 29, or absolute value of negative 29, which equals 29. Okay, and there's 29 feet. All right. And just to finish this off here, E, what is the change in elevation from 140 feet above sea level and 40 feet below sea level? And again, just apply your distance formula. You got the absolute value of 140, because that's the above sea level part, minus a negative 40, because that's the below sea level part there. And then if we just go ahead and work that through, we know we have an absolute, which actually is the absolute value of 140 plus 40, which equals absolute value of 180, which equals 180. Okay, so the answer to that is 180 feet. Okay. Alrighty. So as he's moving, though, he's moved 180 feet, but if he's moving because he's moving from above sea level, okay, to below sea level, if you were going to ask what is his change in elevation now, you have to, it's not the distance anymore, but the change in elevation, and that's going to be a negative 180, okay? So it's going to be a negative 180 feet. Okay, that is his change in elevation because he has actually gone down. Really, really key to look at the question. This one says change in elevation. It doesn't say the distance. He's moved. His change. It's not his change in his distance. Okay, it's actually his change in elevation. Okay, which is that. Okay, so in closing, let's look at our summary again. Okay, so just a few key points here that we learned. To find the distance between two rational numbers, and reading from this one here on the number line. Okay, a number line is you can just count the number of units between the numbers. Okay, always a good way to, especially early on in your career here of using this, is to use a number line at least to check. Okay, to support your answer. All right, the second point here, using a formula. The distance between rational numbers p and q is the absolute value of p minus q. Okay, so again, that's so distance. A couple of really key points and distinctions here. Distance is always positive. We're talking about distance between 2 points, but change may be positive or negative, and we saw those come in terms of temperature, and we also had elevation and elevation gain or loss. Okay, if we're talking about a change in elevation or change in temperature, they could be positive or negative. And there's also other applications too for that, change in wealth, for example. Okay, so again, distance is always positive. Change can be either positive or negative. Okay, thanks, and see you at lesson 7.